Hi, I'm Professor Goings, and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics courses, you've come to the right place. So hit that subscribe button and check out some more videos. Let's get into the current one. What is an infinite set? Well, pretty much at any college mathematics course, the concept of infinity is going to appear somewhere, whether it's in beginning algebra, and you are looking at, say, writing an interval notation from, say, 4 all the way out to infinity. So even in that course, the concept of infinity gets brought up. Calculus, you talk about limits at infinity. Or, in an abstract algebra course, cardinality of a set is infinite. And then you start getting into countable versus uncountable. And so concept of infinity just permeates all college mathematics courses. And so what I want to do is let's formally describe what we mean to say that a set is infinite. Okay, well, first and foremost, let's look at a couple of sets here. All right, let's look at the set 1, 2, 3, 4. And let's also look at the set 1, 2, 3, 4, 5, etc. Okay. So this one stops at 4. It's just the integers that start at 1, end at 4. This one is the integers that start at 1 and then keeps going. It's that keep going thing that kind of tells me, oh, that's infinite, right? Because it keeps going. Well, this one here is finite. If you watch my previous video on what is a finite set, we know that there's a bijection from this set onto the set 1 through 4, which would be itself. Well, here's what I want to show you. I can actually take a subset of this. So before I write out, kind of formally, let's just kind of play around with this. I can take a portion of this set. For example, 2, 4, 6, 8, etc. Right? I can take a portion of that. And what I can actually do is I can show that there is a bijection from this set onto a proper subset. Oh, that one's dry. Let's try this one. It kind of looks the same. The yellow and the green kind of show up the same, but whatever. I can go from 1 to 2, 2 to 4, 3 to 6, 4 to 8, etc. And what this shows me is that the number of elements, if number even makes sense in this context, the amount of elements in this original set of all the positive integers is the same as a proper subset. Now, I can't do that up here, right? Let's say I was to kind of say, all right, well, I'll just take the even integers here again. 2 and 4. Well, I can't create a bijection from a set onto a proper subset for a finite set, but I can do it in the case of an infinite set. And that property that this set has, that this set does not have, is the distinguishing feature between finite versus infinite. Therefore, let's write that out formally. So definition, a set A is infinite if there is a proper subset B of A and a bijection sigma from A to B, or equivalently B to A, because sigma inverse would be a bijection as well. I digress. So a set is infinite. Let me just kind of say this informally. A set's infinite if it has the same number of elements as a proper subset. Not every proper subset, but there is a proper subset that has the same number of elements. For example, 1, 2, 3 is a proper subset of this one, but there's no bijection from all the positive integers onto 1, 2, 3. But we can find a proper subset for which I can get a bijection between that set and that proper subset. So in this case, then, we say that the set is infinite. And of course, this right here, this set 1, 2, 3, 4, which we know is a finite set, lacks that property, and therefore is not an infinite set, because I could take every possible subset. And we write this as the order of A, or the cardinality of A, is infinity. Now, of course, from here, once I say that the cardinality is infinity, we've got, you know, this is going to split into multiple cases, right? Is A countable? Is it uncountable? Is there anything beyond that, right? So what do we mean? Like, just to say that the order of A is infinite doesn't necessarily mean that we know the size of A, because, and I'll do this in a different video, the order of the natural numbers is not the same thing as the order of the real numbers, even though both of these are infinite, right? This one's countable, this one's uncountable. But that's what we mean when we say that a set is infinite, is it has a proper subset with the same number of elements. And this kind of comes back, is tied into, if you watch the short that Professor Van Hamlin talked about, where he said something along the lines of, I'm probably not going to get it the exact formatting right here, but it was something along the lines of like 1 plus infinity is equal to infinity. If you haven't watched that, go ahead and take a look at it. I think that's where he talked about Hilbert's Hotel. But here's, let me kind of tie into that real quick before I wrap this video up. So I can explain that same concept without using Hilbert's Hotel. Let's talk about it in terms of bijections between sets. So let's say I look at the set 1, 2, 3, 4, etc., and then I take a look at the set 0, 1, 2, 3, 4, etc. Well, this one has, and we're going to talk very informally here, this set here has an infinite number of elements. This has 1 through 2, 3, 4, etc., but it also has 0. So if I could take a look at this one, we could say that the cardinality of this, let's say, is infinite. And let's say that the cardinality of this one is, I hate to put an equal to sign here, and I hate to put 1 plus infinity, but I'm going to do it anyway. It's 1 plus infinity, because it's the same number of this with 1 more. However, I can define a bijection, 0 to 1, 2 to 1, 3 to 2, 4 to 3, etc. And therefore, since there's a bijection, they have the same number of elements, or the same measurement of elements, whatever that means. Okay, so thank you for watching, and please consider subscribing.